This is part 2 of section 6.5. I want to solve this system using Cramer's rule. Well, in order to set up my matrix, I really need my x and my y on the same side. So I'm going to rewrite this first equation by subtracting 3y from both sides. So this system is the same thing as 2x minus 3y is equal to 7, and 4x minus 6y is equal to 3. Okay, now we're going to create our d, our dx, and our dy. Our d determinant we make from our coefficients here, 2, 4, -3, and -6. Okay, so let's do our calculations. 2 times -6 minus, it's going to be -3 times 4. And that would equal -12 minus a -12, which is -12 plus 12 is equal to 0. Okay, this is a special case. Now, how do I know it's a special case? Because that is a 0. Okay, that means if you recall from way back when we first started solving systems, we said that we had two kinds of special cases. We had the case where we had the same line, in which case they have infinite solutions, or we have the possibility that these are parallel lines and they have no solution. Okay, some textbooks have you stop right here and they'll say Cramer's rule does not apply. But you can actually keep going and figure out whether you have an inconsistent system or a dependent system. Okay, now one way you can know this is when we're supposed to find our x value, for example, we are supposed to do dx divided by d. Well, d is 0 and we can never divide by 0. So we've got an issue here. Okay, what I'm going to do here, I know I have something weird happening. I have either the same line or I have parallel lines. I'm going to keep going. I'm going to figure out what dx is. Now remember, to find dx, you're going to come back here, but you're going to cover up your x values with your answers, a 7 and a 3. So if I cover those up, I get 7, 3, -3, -6. Now, if I get a 0 here, then I'm going to calculate dy. If all three of them are 0, then I have the same line. If this is anything other than 0, I have parallel lines. So let's do this calculation. Okay, 7 times -6 minus -3 times 3. That gives me -42 minus a -9, which gives me -33. Okay, which is not 0. Okay, so this is an inconsistent system. Okay, and when we did it before, this is where you would end up with something like, after you're using the addition method or something, all your variables would go away and it would be equal to something that's not true. This case is the same as this when we were doing addition or even substitution. Okay, there's no solution. These are parallel lines. Okay, so let's use the Cramer's rule for this one. First thing we need to do, everything is in the right order, our x's, then our y's, and then our constants. So I'm going to find d, and that would be 4, -20, 9, negative 45. Okay. So we need to multiply 4 times negative 45 minus 9 times negative 20 okay. This gives me negative 180 minus a negative 180, which is 0. So I have another special case. And just because you know this is a class, you probably recognize that this is going to be the other case. But let's keep going. I got 0. I know I'm not going to get a single solution. I might be all real numbers. It might, not all real numbers, infinite solutions, or it might be no solution. Let's keep going. I want to find dx. And remember, if this is anything other than 0, it's inconsistent. If it's 0, then I'll need to check dy. And then, but if all three of them are 0, then we have the same line. Now remember, to find dx, you want to cover up your x column with your answers. So I have a 3 and a negative 15. I'm going to put right there. So I need to calculate this determinant. Okay. So that would be 3 times negative 45 minus 9 times negative 15 This gives me negative 135 minus a negative 135. So this is 0 as well. So far, it looks like I may have the same line, but again, it all depends on dy. If dy is anything other than 0, I have an inconsistent system. So let's find dy. For dy, we cover up our y's instead of our x's. So what I need to calculate is this determinant for negative 20, 3, that looks like a double negative and it shouldn't be, 3 and negative 15 right here. Okay, so I do 4 times negative 15 minus 3 times negative 20 and this will give me negative 60 minus a negative 60, which is 0. So these are all 0. Okay, this is a dependent system. Okay, and that means they are the same line. So, and also infinite solutions. All of these are saying the same things. Now, I corrected myself earlier. At first I said all real numbers, and it's not all real numbers. Remember, if these are the same line, it's where they cross, and they cross on every single point on the line. There are infinite points on the line, so there are infinite solutions. But this point right here is not a solution. So it's infinite, but not everything. You're usually asked to write these answers in set builder notation, and they provide this part for you. And all you're supposed to do is to write down the equation here, and you want to write down the most general one. This has bigger numbers. Everything can be quote-unquote reduced by dividing everything by negative 5. In fact, if you do that, you get exactly this. I'm going to put 4x plus 9y equal to 3 in that position, and that will be my overall answer. This stuff is not difficult. You just need to be really careful with your signs, especially since you're subtracting two things and you're going to end up with double negatives a lot. Just make sure that you aren't accidentally dropping a negative And you can always, of course, check your answers. After you get your x and your y, you can plug them back in, and it should work in both of them.